of our lifetime energy model. As many of you know, and what's typically accustomed to downloading our A760, and that A760 can be generated either with our system advisory model or the DNV solar farmer model. What many people are not utilizing to the fullest, and that's what this video is all about, is our lifetime energy model. Now, you may ask, why use the lifetime energy model? I've been using A760 this whole time. And what typically happens is you take that A760 as designers, engineers, and you ship that over to your sales team and project. Eventually, it goes to project finance. And what project finance does is they take that A760 and they project that information from year one all the way to the lifetime of the project. So say the project year's 30, the lifetime is 30 years. Sometimes you can go up to 35, 40 years for these projects. They're going to project that and they're going to apply their degradation and unavailability for all those years that that project exists. Now, you may ask, why do we want to take this on as engineers and designers to do this ourselves? Well, the big key insight here, there's two big key insights. One is that unavailability is not linear throughout all the years. You actually have adjustable unavailability based off of the years of the project. And the other one is degradation. And this degradation is key to understanding and unlocking more energy from your project in a real life scenario. So I want to show you this chart. I actually wrote an article that's published in PV Magazine. We have this linked on our website. But essentially what this chart shows is the blue line is your DC production on a nice, good summer's day. And this green line right here, this light green line, is your AC output. And now you notice, well, why is it stopping here? It's because you're clipping that system. This system has a 1.6 DC to AC ratio. Any system that has over a 1 DC to AC ratio will experience some clipping throughout the project lifecycle. And so what happens is that you're taking this DC and then you're taking this AC out, and that AC out, you're putting in that A760 and then taking to your project finance team. And the crucial insight here is that that project finance team, when they degrade it, they're going to be degrading this AC green line, which is not what's actually being degraded. None of the AC components degrade. If they're either working or they're failing. For PV modules, the PV modules on the DC side of the system are what is being degraded as the lifetime goes on. And so when your project finance team takes this AC model and they degrade it, they get this dark green line here. That's what they're degraded at say 30 years in the future. But you're degrading that clip value. That's not actually representing this site correctly. What's the best way to do it is to take this blue, which is the DC power, degrade the DC power, which is what this purple line is, and then apply clipping based off of those inverters for every hour or time step that you have in the system. And as you can see, the difference between this pink line right here and this dark green line, that shaded area, that's all energy that you realistically have for your solar system that you're not accounting for if you're letting project finance degrade the system. Now, it's not to say that project finance isn't doing a bad job. This is how most people do it, but you're missing anywhere from 30 to 100 basis points of production by doing it the old way. We in Celestica have enabled this tool that allows you to do it directly in Celestica. So say you know when you're going to be operating this project, we know November 20th it's going to turn on, right? So that's when day one, year zero, that's your year zero, day one mark, right? You know the lifetime's going to be 35 years. You have an annual degradation. And then likewise, we have a formula that's based off of a DNV white paper based off your project size, your system type, and some other factors, what your specific year-to-year unavailability should be. You could also set this to be a constant value here, or you can adjust specific years here. Likewise, you can adjust this annual degradation rate to whatever you'd like, the operation date and the project lifetime. So let's download this for a moment. And what you're going to see is that we generate a month-by-month value for you. Give me a second. That's the old one. And so it starts on the day that we PTO, and then it goes all the way for 35 years to the end of that project lifetime. And so this accurately accounts for each project year's degradation and availability. It takes the unavailability that we did for year specific, applies it to that project year, and it also takes that degradation and applies it on that DC side of the system, so you gain and actually represent the real production of the system. This is a tool that we have designed so that you can directly take this and give this to whoever's doing the project finance. Instead of them dealing with 8760 data, they're dealing with now this monthly data. This works for any solution that requires monthly data and not hourly data. Obviously, if you require hourly, the best way to do that would be to continue to use our 8760 function. I hope this is very helpful, and I hope you have a great day.